the top term again?
This top term?
It's the qx1 to
So
xi
this-
minus 1 given what?
No, it's not given. That's 1 in the xi position.
Oh.
So it's basically a vector from x1 to xi, where it's everything specified from x1 to xi minus 1, and then 1 in the ith position.
Thanks.
So, we know that q of x1, x2, and so on up to xi minus 1 is equal to, this is just what we showed before, 1 over n plus 1, 1 over n choose k. So therefore, q of x1, x2, and so on up to xi minus 1 with a 1 in the xi position, basically it's, excuse me, this is wrong. It's correct, it's just the notation is wrong. So instead of n, I should have I minus 1, so that's I minus 1 plus 1. 1 over I. And this is I minus 1. And then k, I'm going to put k, the subscript on k will be I minus 1, just to indicate that that's the number of ones from position 1 to position I minus 1. So let me be a little more clear. K, excuse me, I minus 1, choose k I minus 1. Okay, if I stick a 1 on the end, if I stick a 1 on the end, I have well, for one thing, my sequence length, this is 1 over n plus 1, 1 over n choose k. In this case, n, the number of symbols, is I. So this is now I plus 1. So n is I. And now how many 1s do I have? I had k I minus 1 ones from here to here. And I have an additional 1. So this must be I choose k I minus 1 plus 1. Okay, so we can substitute everything in here, and we get this guy in the numerator. So that's 1 over I plus 1. I choose ki plus 1 plus 1, ki minus 1 plus 1 is in the denominator I factorial. In the numerator, ki minus 1 plus 1 minus, excuse me, ki minus 1 factorial, rats, ki minus 1 plus 1 factorial times, I'm going to run out of space here. So this expression, right here. And for clarity, let's just expand these expressions. This is 1 over I plus 1. This is I factorial in the denominator, ki minus 1 plus 1 factorial, I minus ki minus 1 minus 1 factorial. And this is 1 over I times 1 over I minus 1 factorial ki minus 1 minus, excuse me, I minus 1 minus k minus 1 factorial. So we end up with 1 over, in the numerator, 1 over I plus 1, ki minus 1 plus 1 factorial, I minus ki minus 1 minus 1 factorial, divided by I factorial. Then in the denominator, it's this one, times 1 over I is I, times 1 over this, which is I minus 1 factorial, divided by k I minus 1 factorial, I minus 1 minus k minus ki minus 1 factorial. Okay, this term and this term are the same. Excuse me, just this term, just the term in brackets here. I factorial times, excuse me, I minus 1 factorial divided by I factorial is 1 over I. Yeah, this I factorial divided, or excuse me, I minus 1 factorial divided by I factorial is 1 over I, and I have an I here. So those cancel. And what I'm left with is ki minus 1 plus 1 factorial divided by ki minus 1, which is,
Yeah, minus 1 plus 1.
yeah, so I end up with ki minus 1 plus 1 divided by I plus 1. Okay, so that basically, if you think about starting at I equals 0, actually the first element you should start with is 1. So if I is 1, the number of 1s you have up to, but not including the first element, should be 0. So that you end up with 0 plus 1 divided by 1 plus 1, which is 1/2. So you always believe, you have no belief on the first symbol. So your first symbol, you start off with 1/2. I think that is a good note on which to stop, and we'll come back to this next time with an example.